Hello students, welcome back. So now we are going to be talking about matrix. We're going to be talking about matrix addition, subtraction, and multiplication. What exactly is a matrix? Well, it is a grid of numbers. So in two-dimensional matrix, you have rows and columns. So suppose these are your numbers right here. 2, 5, 1, 1, 3, 7. This is a matrix right here. In this case right here, these are called rows. This is my row 1. This whole number, this thing is my row 1. And this one right here is my row 2. This one right here is my column 1. This is column 2, and this is column 3. Now, the shape of this matrix is 2 by 3 because you have two rows. So you say two rows and you have three columns. And that's why you say 2 by 3. You always specify your row first and your column next. Now, matrices, they can be used to represent data. For example, a data set where your rows, that would be samples, and your columns would be features. So suppose you have a table like this. This is a small table, and in this table, you have three columns: age, income, experience. Another name for that is features. This is your age feature, this is your income feature, and this is your experience feature right here. And these are the corresponding data. So some guy, his age is 23, his income is 45,000, his experience is 6. And likewise, this is the information for the second guy, third guy, and fourth guy. You can represent this information in a matrix notation. So I'm actually representing this by 23, 45,000, 6 right here, 61, 65,000, 4. And you can see that this number, this whole table can be represented in this matrix notation. This one right here, this is my feature 1. That would be my age feature. This is my feature 2, this column right here. That would be my income feature. And likewise, this would be my experience feature. This right here, each one of the rows, this row right here, this whole row, that is my data. That is my data for sample 1. This one is my data for sample 2, data for sample 3, and sample 4, and so on and so forth. You can also use matrices to represent images. And so suppose you have an image like this. This is an input image. Let's say this is an image which is 4 by 4 pixel. You have 1, 2, 3, 4. 4 pixel in this direction, 1, 2, 3, 4, and 4 pixel in this direction. Total 16 pixels. So this pixel, it can be represented in matrix notation. Suppose your white color, your extreme white, that could be 255, and your black color, that would be these numbers, they would be your 0. So this matrix can be represented by these numbers. 203, that means it is like kind of more towards white. This is 0 because this is black. This is 0 because this is black. This is 200. Well, that's because this is white, but not all the way to the pure white. It's like almost kind of a little bit grayish. Then you have black, black, and then you have 30, which is kind of gray, but that would be right here. You can see it's kind of a little gray. And then look at this one. This is 49, 49. So this is kind of a little bit gray. So I'm able to represent this image in the form of a matrix. And now I'm going to talk about matrix addition, subtraction, and multiplication. So matrix addition, subtraction. Well, in order for addition or subtraction to occur for a two matrix, the shape of the matrix, they must be same. So for example, let's take a look at this matrix. This is my matrix A. The shape is 2 by 2. It has two rows and two columns. This matrix right here, it also has a shape 2 by 2. It has two rows and two columns. So this shape is exactly same as this shape. So I can perform matrix addition over here. And the way you do matrix addition, you just add the corresponding elements. So you add 2 to the 1 and you get 2 plus 1. Then you add 3 to 7. You get 3 plus 7. You add 1 to 9. You get 1 plus 9. And then you add minus 5 to 6. And then you get minus 5 plus 6. And you solve it, and this is your matrix right here. 3, 10, 10, 1. And the shape of this matrix is going to be 2 by 2. Same as the shape of these matrices. For example, this one right here. This one actually has a shape 2 by 2. This one has three rows and two columns. Well, in this case, I cannot add, I cannot perform addition or subtraction. That's because my shape is not same. Look at this one. This is my matrix subtraction now. I have this matrix A, this is my matrix B. Shape is 2 by 2, 2 by 2. I can perform subtraction now. So the way you perform subtraction, same principle. You take 2 and 1, subtract 2 minus 1, take 3 and 7, subtract 3 minus 7, take 1 minus 9, 1 minus 9, and likewise minus 5 and minus 6, minus 5 minus 6. And you solve it, and this is your matrix right here. And final matrix is going to be 2 by 2. So if this is 2 by 2, your final is going to be the same shape. And now comes matrix multiplication. Well, the rule is this. Suppose you have this matrix, matrix A and matrix B, and you want to multiply them. And the shape of matrix A is m by n, and the shape of matrix B is n by p. As long as this n, okay, is same as this n. In other words, the number of columns in matrix A is same as the number of rows in matrix B, then you can perform matrix multiplication. So they must be same. Now when you do matrix multiplication, your final matrix is going to be m by p. That is going to be the shape of your matrix C. So this is my m right here, and this is my p, so it's going to be m by p. So for example, let's take a look at this example. Here I have two matrices, A and B. The shape of this matrix is 2 by 2, and the shape of this matrix is 2 by 2. This 2 is same as this 2. So matrix multiplication is possible. And your final matrix C, it is going to be 2 by 2. This 2 by this 2. Let's take a look at this one right here. This is my matrix A. This is my matrix B. The shape of this matrix is 2 by 2. 2 rows, 2 columns. The shape of this matrix is 2 by 3. I have 2 rows and 3 columns. Well, this 2 is same as this 2. So the matrix multiplication is possible. Now, your final matrix is going to look like 2 by 3. 2 by 3. Let's take a look at this one right here. Here, I have this matrix A and B. This one actually has 2 by 2. This is 3 by 2. Well, this 2 is not same as this 3. So because they are not same, so the matrix multiplication is not possible over here. So how do you perform matrix multiplication? Well, let's understand this with a simple example. Suppose I have two matrices, matrix A and matrix B. Matrix A, I'm going to assume is 2 by 2, and matrix B is, let's say, 2 by 2. So the way you do is you create this matrix C. And let's say your matrix C would be C11, C12. By the way this subscript works in matrix multiplication, let's say I say A12. This one refers to the row number. Would be your row number. And this one right here would refer to your column number. So this one right here is telling me that this element is in row 1 and column 2. So this one right here is telling me that this is C, and this C is for row 1 and column 2. So how do you find this C11, C12, C21, C22? Well, this is the rule we use right here. C11 would be equal to the row 1 of A dot product with column 1 of B. C12 would be row 1 of A dot product with column 2 of B. Likewise, C21 would be row 2 of A dot product with column 1 of B. So what's happening is basically I'm just taking these numbers right here, and I'm doing dot product with this one, then I'm doing dot product with this one, then I'm taking this number and I'm doing the same thing, dot product with this and dot product with that. So let's understand this with an example. So suppose you have matrix A and matrix B, and you want to perform multiplication, matrix multiplication. You want something like this, C equal to AB. So this is my matrix A right here. This is matrix B. Now this one actually has 2 by 2, and this one also has 2 by 2. My 2 and 2 are same. That means I can perform matrix multiplication. Now my final matrix is going to be 2 by 2. So 2 rows and 2 columns. So I have 2 rows right here, okay, and 2 columns. You can see that. Now in this case, what I'm doing is my first one. This would be my C11. This is going to take the row 1 of matrix A. Let's say this is my A and this is my B right here. So it's going to take row 1 of matrix A dot product with column 1 of matrix 2. And this is exactly what's happening. 1 comma 2 dot product with 5 7. Well, this is my C12. This is going to be the dot product of row 1 from column A, dot product of row 1 from matrix A with column 2 of matrix B. And this is exactly what's happening. 1 comma 2 dot product 6 comma 8. Now let's take a look at this one. This is your C21. So this is going to be dot product of row 2 matrix A, that would be this right here, dot product with column 1 of matrix B, that would be this right here. So you can see that it's dot product with that element. Let's take a look at this one, C22. This is going to be the dot product of row 2 matrix A with column 2 of matrix B. And this is exactly what's happening over here. Now you know how to perform dot product. So let's do this one. So the way you do dot product is you multiply 1 by 5, okay, and you plus 2 by 7. So 1 by 5 plus 2 by 7. This is how you do dot product. And likewise, you can do the dot product of this, dot product of this, and dot product of this. And your answer will come out to be this right here. So when you multiply these two metrics, A and B, this is your final result. Now, some of you may come from a math background and may want to know how to calculate the coefficient. What is the exact formula to calculate the coefficient of the matrix C? So suppose this is your matrix C right here. This is my C11, C12, so on and so forth. And let's suppose your Cij is any general element in your matrix C. So the formula for Cij, in other words, how you calculate the any element in the matrix C would be using this formula right here. And what this formula says is that you take the row I to calculate your Cij, you take the row I from A, and you take the column J from B, and then you do the dot product. In other words, you multiply matching elements and then you add them all together. This is how you calculate your Cij. And now let's perform one last matrix multiplication. Suppose you have matrix A. This is 2 by 2. Matrix B is 2 by 3. This 2 matches with this 2. So we can perform matrix multiplication. Your final matrix is going to be 2 by 3. So this is my final matrix C, and this is 2 by 3. So in this case, you're going to have C11, C12, C13, C21, C22, C23. You have all this thing. This 2 right here, this 2 right there, this refers to the row, and this 3 right here refers to the column. So how do you calculate your C11? Well, we're gonna use the logic I just showed you. So we're gonna take the row 1 of matrix A, dot product with column 1 of matrix B. This will give you this element right here. C12, you're gonna take the row 1 of matrix A and dot product with column 2 of matrix B. That will give you this element right here. C13, you're gonna take the row 1 of column A of matrix A, dot product with column 3 of matrix B. That will give you this right here. This one over here, C21, you're going to take the row 2 of matrix A, dot product with column 1 of matrix B. And this is how I got this. And likewise with this one and this one. And this way you can figure out and do the computation. You will get your C matrix. And now the applications of matrix multiplication. So I'm going to show you a few applications. Matrix multiplication, they're used to perform linear transformation. For example, you can do scaling or rotation of images. So let's take a look at a scaling matrix. Suppose you have a matrix in 2D, this one right here. So this is my Sx 0, 0, Sy. And what Sx and Sy are, these are just numbers. Now in this case, this is called a scaling matrix. Your Sx and Sy, they actually allow you to scale in the X direction. And Sy right here would scale it along Y direction. So what do you mean by this scaling? Let's take a look at an example. Suppose this is my matrix right here, S, 2, 3, and this is a point, 1, 1. Let's say this is the point right here. This is my point P. And if I take this point matrix P and I multiply by matrix S, so if you look at this matrix S and multiply by the point P, this will give you, using matrix multiplication, this answer. So your point 1, 1 has transformed to 2, 3. That means your 1, 1 right here, it became 2, 3 because of the multiplication with this scaling matrix. So if you look at this 1, 1, what just happened? This 1, 1 changed to this 2, 3 right here. This is my S dot P. This has been scaled. If you look over here, what just happened was that this point 1 has been scaled along the x-axis by 2. So this one right here, it actually got over here. And likewise, your y, that is this one right here, it got scaled along the y-axis by 3. And this one actually went 3 unit in this direction. So This 2 is responsible for scaling along x-axis. This one is responsible for scaling along y-axis. Now let's take a look at an example of a rotation matrix. Rotation matrix, it rotates a vector. It does not change the magnitude of a vector. So suppose you have a rotation matrix. So let's say you want to do rotation in 2D. So your rotation matrix will look something like this. This is saying r theta equal to cos theta minus sine theta, cos theta. Theta is the angle by which you're rotating a vector. So let's say this is my vector P, and I'm going to rotate by angle theta right here. So I'm going to do this matrix. I'm going to use this matrix, cos theta minus sine theta, and cos theta. Theta is your rotation angle. Suppose you want to rotate by 90 degree. So your r theta, in other words, r 90 degree will become cos 90 minus sine 90, cos 90. And you substitute the values over there. This is your r rotation matrix now. Suppose your point P is 1, 0. That would be this right here. This is my point. This is my vector 1, 0. And you multiply this by r. So I'm doing rp. So you do your normal matrix multiplication, and let's say your answer comes out to be this. Actually, not let's say, this is your answer right here, 0, 1. So what just happened? This point 1, 0, it turned into 0, 1. And you can see that it actually got rotated by 90 degree. Your 0, 1 is along y-axis right here. So this is my x-axis, and this is my y-axis. So your point 1, 0, after performing the rotation, in other words, after multiplying with this matrix, it has turned into 0, 1. It has rotated by 90 degree. And now we can do scaling and rotation. In other words, we can actually combine them together. So this is called transformation. So let's suppose you want to do scaling first and then you want to do rotation. So you take scaling, multiply by rotation. So suppose your scaling vector is the same one as the previous one. This is my scaling vector. And let's say this is my rotation vector right here. So my transformation vector is going to be r dot s. So multiply your r vector by s vector. And let's say this is your answer right here. So this particular matrix is responsible for first scaling your vector, and then it's going to do rotation. So suppose you have a point 1, 1. Let's say this is my point right here, 1, 1, and you multiply this 1, 1 by this matrix T right here. So I'm multiplying T by P. You do matrix multiplication and it will come out to be this. So this point 1, 1, after you applied transformation to that. So let's say this is my P right here, and you apply T dot P to that. Okay, you multiply matrix T by P, and your point is going to become minus 3, 2. So your 1, 1 has been transformed to a new point, minus 3 comma 2. And this is what happens when you do image transformation. When you move an image, when you distort images and stuff like that, this is exactly what's happening. So uses of matrix multiplication. Well, in your graphics or robotics, every time you perform scaling or rotation, or let's say transforming an image, you are doing matrix multiplication. In machine learning, when you perform scaling or transforming data, you are doing matrix multiplication. Every time when you rotate or zoom an image, behind the scene, matrix multiplication is happening. Suppose you have an image and you want to blur it. Let's say this is your image right here. It's a 3 by 3 pixel. And you want to blur this image. In this particular image, 0 means black, 255 means white. So what you can do, you can apply matrix operation. And this is your matrix, let's say. And this is called a blur filter. So I take this matrix, this is my image, and this image basically could be something like this. So you can see that 255, 255, 255, these are my diagonals. So all my diagonals are white, 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 and rest of the other elements are all zero. Are all black. So this is a 3 by 3 pixel. You can see 3 pixels in this direction and 3 pixel in this direction. And so you multiply this by the blur filter, which is this one right here. So you multiply this matrix by this matrix. In other words, when you take this image and you apply this blur filter, it will give you a number like this. And if you look at these numbers, they are 28.3, 28.3. These are your numbers. So now your image, when you convert this into an image, it will look something like this. So your image has become blurred. In other words, what just happened was matrix multiplication.